Okay, you're watching 11.4 on geometric series now. So talking about still getting from one number to the next by using multiplication, because that's what our geometric part of this means. But series just means that we're adding them all up. So 1, 3, 9, 27, 81, we can clearly see that we're multiplying by 3 to get to the next number. To make it a series, we're just going to add them. So just like our 11.2 notes. Same thing here, 5 plus a negative 10 plus 20 makes it a series. 4 plus 1 plus 1/4 plus 1/16 makes it a series. So here you can see that we're multiplying by 1/4 because we're getting smaller. Remember, we're multiplying by a fraction then. Here, because our sign is changing, we're multiplying by a negative. So how do we get from 5 to 10? Well, we multiply by 2, but to get to negative 10, we multiply by negative 2. So the sum of a geometric series, another formula to remember. S of n equals a sub 1 minus a sub 1 times r to the n power all over 1 minus r. Or, because of course we have to have two formulas, S of n equals a sub 1 minus a sub n times r all over 1 minus r. Now you're going to see that the differences in these two formulas is here you don't have an a sub n, and here you do. That's basically your differences, okay? So let's take a look at some examples, and we're going to be kind of playing with both of these formulas. Let's go ahead and use the first formula on this first one, so I'm just going to rewrite it as S of n equals a sub 1 minus a sub 1 times r to the n all over 1 minus r, so that way that you know in your notes which one you used. So number 1 says find the sum of the first 6 terms of the geometric series for which a sub 1 is 5 and r is negative 2. Now remember, the n in all of these is the number of terms in the series. So because we are finding the first 6 terms, our n is 6. Okay, so just kind of a thing to keep in mind. So now, let's plug in our information that we know. We know our a sub 1 is 5, minus our a sub 1 is 5 again, times my r, which is a negative 2. Notice I'm putting it in parentheses, especially when it's a negative, raised to the n power. Now, because we're finding the first 6 terms, we're going to raise it to the 6th, all over 1 minus my r, which is again a negative 2, and I'm going to keep that in parentheses. So simplifying this out, order of operations, I'm going to take care of my exponent first. Negative 2 to the 6th power is going to give me a positive 64, all over, now 1 minus a negative 2 is the same thing as 1 plus 2, correct? So on top I have 5 minus, now I'm going to multiply 5 and 64 to get 320. Simplifying my bottom, I get just a 3. 5 minus 20, of course, is going to give me a negative 315 all over 3. And dividing that, I get a negative 105. Now remember, can a sum be negative? Can you add up a certain amount of numbers, in this case 6 of them, and your answer be negative? Well, yes. Think about this series. Our first term is 5. And to get to the next term, we multiply by a negative 2, so that's going to give us a negative 10. Multiply by a negative 2, that gives us 20. Multiply by a negative 2, that gives us a negative 40. So yes, our negatives are going to start to overpower our positives. Now, could we have just done this and then added the 6 times together? Yes, you could do that as well. This again is, I'm just showing you that you can use formulas to do these, because all of a sudden these questions are going to say find the first 100 terms of the geometric series. You're not going to do that by hand. You're not going to want to do that by hand. Number 2, find the sum of the geometric series for which a1 is 729, an is negative 3, and our r, we're going to change actually to a negative 1/3. So I want you to put a negative 1/3 on there. There has to be a negative on there because first of all, our first term was 729, and then we went so many terms, and then our last term was a negative 3. So there has to be a negative in there, remember, because we're multiplying to get from one number to the next, not just adding by a negative. Okay, so let's go ahead and use the second formula on this one. So a sub n equals, or I'm sorry, s of n equals a sub 1 minus a sub n times r all over 1 minus r. Bottom's easy to remember because it's the same on both. Let's plug in what we know. Our a sub 1 is 729. My a sub n is a negative 3. And my r is a negative 1/3. Now the reason I picked the second one to use is because we know our a sub n. First one, we don't have an a sub n spot to plug in. This one we know our a sub n. So let's use let's use the one with the a sub n in it, right? 1 minus r would be 1 minus a negative 1/3. Okay, simplifying. We're actually going to come up here where I have a little bit more room. Maybe not. We'll see if we can fit it down here. So simplifying, I'm going to multiply first. I get 729 minus, now a negative 3 times a negative 1/3 is just a positive 1. But I'm going to write just a positive 1, just like that, over 1 minus a negative 1/3. Well, first of all, this is going to change to plus. 1 plus 1/3. Now this is like we have 3 over 3 plus 1 over 3. 729 minus 1 on top is just going to give me 728. Over 3 over 3 plus 1 over 3 is just 4/3, and again that's something you can use your calculator for. And then I have 728 divided by 4 over 3, and in order to divide by a fraction we're going to multiply by its reciprocal. So 728 times 3 over 4, and then I just put that in a calculator and I got 546. And there is my solution for that answer. Last one. Find a sub 1 in a geometric series for which you already know that the sum of the first 7 terms is 70,933 and r is 4. So how do you get from one number to the next? So now, let's go ahead, let's use our first one because we don't know an a sub n and we're not looking for an a sub n, so it doesn't make sense to use the one with the a sub n in it. So let's use our first. S of n equals a sub 1 minus a sub 1 times r to the nth power all over 1 minus r. So I'm just rewriting what my formula is. Now you're going to notice that both of these terms have a sub 1 in it. So what I'm going to do is but even before I plug in any numbers, I'm going to take the a sub 1 out. I'm going to factor it out. Now if I factor out this a sub 1 from each of these terms, what do I have left? Well, I have a sub 1 divided by a sub 1, which is just 1, minus, and then this is gone, I just have r to the nth power. So what this is going to do is it's just going to help us be able to solve for the a sub 1 a little bit easier. A little bit less steps later on. So now I'm going to plug in what I know. S of 7, that's my S of n, okay, even though it says an n here and it says a 7 here, it's the same thing, okay. S of 7 is 7, actually let's go ahead and let's do this in 2 separate steps. S of 7 equals a sub 1 times 1 minus r, and then let's plug in a 7 for our n, over 1 minus r. Now let's plug in some numbers. 70933, which is my S of 7, equals my a sub 1, which I do not know, so I'm going to just leave it as a sub 1, times 1 minus r, which is 4, to the 7th power, all over 1 minus r again, which is 4. Okay, we are solving, so I'm going to come up here, bring my work up here. 70933, nothing to do on the left side. On the right side, I'm going to simplify inside this parenthesis right here. So I have a sub 1 times, if I plug in 1 minus 4 to the 7th power, my calculator does the work for me, and I get negative 16,383 all over 1 minus 4, which is just a negative 3. Now I'm going to divide this part right here. So simplifying even further. And I get a sub 1 times 5,461. I know they look like huge numbers, but it's okay, we'll be fine. Divide by 5461 on both sides. And we get a sub 1 equals 70,933 divided by 5461. And it's actually a pretty big number, but we're going to round to a couple spots, is 12.99. So let's just go ahead and make a note to ourselves. Round to 2 spots. after the decimal. So the nearest hundredth. And there's our answer. We are done. Okay, so those are going to be the longer of the problems in this section for sure.